about the SciAps line of handheld instruments, and also a little bit about our academic loaner program, and how else we can help you with our technology here. My name's Morgan Jennings. This is Bianca.
Hello.
And we're here to tell you all about SciAps. So thanks for coming. So a couple things I want to mention. It looks like we have a few people viewing at the moment. If you have any questions or anything you'd like us to focus on along the way, just type in your questions or what you're interested in. We can try to focus the demonstration along those lines for you. Or if you can just tell us kind of what your background is like, we can also try to focus in on things that would be more interesting to you.
Just 1 second. Somebody asked us to pump up the volume.
We're recording that.
Perfect.
Hopefully this is better. Thanks for that.
Thank you, Marco.
Let us know if it's still hard to hear, but for now, we'll keep going. So, starting off, basically a little bit about SciAps. We specialize in handheld instrumentation, portable instruments just like this. And this product I'm holding is the X550 XRF analyzer. It's our latest product, and we just released it for geochemistry market about a week ago. So we're really excited about that for AGU. And then this here is Libs analyzer. This is called the Z300. And I'll kind of jump in, talk a little bit about the differences between the two technologies. Both have their strengths, and they're a little bit complementary in some ways. So I'll explain how that works. So first off with the Libs, this is the Z300, and the technology is laser-induced breakdown spectroscopy, or Libs for short. And one of the best things about this technology is that you can actually see almost any element on the periodic table. So other handheld elemental analyzers like XRF have been limited by basically not being able to measure things lighter than magnesium or lower atomic number than 12 on the periodic table. The great thing about Libs is that you can actually measure those elements lighter than magnesium. So you can see lithium, you can see carbon, you can see hydrogen, sodium. You can see all that cool stuff, along with the heavy metals as well. So the Libs can do it all. This uses a laser technique. So what's happening is when you pull the trigger, it's going to fire a laser that's got a really fine focal point. It's a short pulse duration, and it's high energy. So there's a lot of energy going into a small area over a very small period of time. And that's enough to actually heat the surface of the sample up to many thousands of degrees and create a plasma. What we do then is we capture that light coming from the plasma, and we chop it up into a spectrum. And what's cool about that light is that different wavelengths of the light are characteristic of the different elements in the sample. So some elements will produce, say, 1 or 2 strong emission lines in your Libs spectrum. Other elements will produce hundreds or thousands of emission lines. So that's another kind of interesting difference between XRF. If you've ever looked at an XRF spectrum, typically you're only looking at 1, maybe 2 peaks per element, whereas Libs you could be looking up at hundreds or thousands. So this is a laser-based technique, so that means you don't have to worry at all about X-ray radiation. You can do cool things like actually test a sample right in your hand like this and not worry about X-rays going through the sample and interacting with your hand, because there are no X-rays. You would never want to do that with an XRF, for example. Hold a sample like this and pull the trigger. The other thing about Libs from an analytical point of view is that it's highly empirical calibration based. So to get good quantitative results, you really want to have matrix matched calibration to go along with it. So typically what people will do, they'll start off maybe just shooting a sample with our Element Pro app, which will give you an idea what elements are there. More of a qualitative thing, what's there, what's not, as opposed to how much of an element is there. From there, if they feel like they want to get good quantitative results out, then they'll build their own calibration using matrix matched known calibration standards. So I think that's probably enough background on the Libs. I'll just show you a quick demonstration of that Element Pro software I mentioned. Let's see if we can do this. So first, I'm going to take a test, and then I'll switch to this other camera view once the test is complete, just so you can see what happens. So I'm just holding the sample in front, and then I'll pull the trigger, and you'll hear the laser fire here. Hold on one sec. So that loud snapping is actually the laser hitting the sample, creating a plasma. And then what you're left with, if we switch cameras, I'll try to show you what's on the screen here. Might be a little bright, but let's see if that comes into focus.
Just go in really close and then pull it back a little bit. And we'll adjust. Yep.
There we go. All right, so this is actually a sample of a mineral called spodumene, which is a high lithium mineral. It also has a lot of aluminum and silicon. So that's why when we shoot it in this qualitative app called Element Pro, we see lithium, aluminum, silicon all at the top of the list of elements detected. You also see these green numbers. Those are not percentages. We call them relative abundances, but really they're just there to tell you, how much of this, how strong is this signal in the spectrum relative to the other elements in the spectrum. So it's not a percentage, but it can give you a rough idea if there's a lot or a little. Also notice that we've detected oxygen in this sample. So that's one of the cool things, one of the best things about Libs. You can measure these light elements that you couldn't do before, like lithium, oxygen. We also see a fair amount of calcium and sodium in this result. And that's, even though that may not be a part of the mineral makeup, those are common surface contaminants, and they're also super bright responders for Libs. So we'll see calcium and sodium in almost anything, just because they're such a strong responder, and you find them in nature all over the place. So so that's a quick look at what the Element Pro app does. And if you're ever wondering, maybe you're surprised to see lithium in a sample, so you want to know, hey, can I actually see these lithium peaks in the spectrum? You can tap on lithium and then tap on the spectrum, and we can jump in and actually visibly confirm, oh, there's the nice lithium 610 line at 610 nanometers, and then here's the other strong lithium line up at 670. So it's a really easy way to get a quick qualitative analysis of your sample to understand what you're looking at, but not necessarily how much. So I'm going to run a quick experiment side by side with the XRF just to show you kind of the differences. So that was Libs, laser-based optical emission technique that can see even very light elements like lithium, hydrogen, oxygen. This is XRF, and the lightest element this model can pick up is magnesium. So the nice thing about XRF is that it's much less dependent on empirical calibration. So we ship this model with a really nice factory-built calibration that should do quite well on almost any geological matrix. So right out of the box, you can actually get pretty good quantitative results. which then you could go in and optimize if you wanted to, but a lot of people find they don't have to. So I'll just show you a quick analysis of that same sample with XRF. So now I'll switch over to the screen here. Thanks, Rick.
Zoom in and it'll cause it to refocus. Re-expose and then out. Yep.
There we go. All right. So I'll try to hold this still while I talk about the results here. So the first thing you'll notice is that instead of that kind of rough relative abundance number I mentioned on the Libs, we're actually seeing percentages here. So that's because this is a calibrated mode designed for geological samples, and it uses an algorithm called fundamental parameters, which allows you to get these nice bulk chemistry and also trace level quantification. So first off, you see aluminum, silicon up around 15-20%. Then you see some trace level elements down below, down to ppm levels. And this was a really quick test, only a few seconds. So I want to jump back up to this LE number at the top of the screen. If you remember when we shot this spodumene sample with the Libs, one of the first elements that showed up was a major component of spodumene, lithium. And that is missing when we shoot it with XRF. So that's because lithium is a pretty light element. It's actually too light to detect with XRF. So all those light elements that we cannot measure with XRF end up getting kind of grouped together in an estimated number called LE. That's that blue number at the top of the screen. So that's representative light element, and it's our way of estimating all the light stuff that's too hard to measure directly with XRF. And the physics behind that is that those lighter elements, as you move to lower and lower atomic number or lighter atomic mass, the X-rays that come from those elements are generally less and less energetic. So they have when you reach something like magnesium or sodium even, more and more of those X-rays are being absorbed by the air before they can reach your detector. So that's why we're limited with XRF. We're losing a lot of those X-rays coming from the sample to the air before we can measure them. Okay, so maybe we could switch back. That was just a quick demonstration of one sample, a mineral that has a fair amount of light element, lithium in it, what it looks like between the two different technologies. So that's a quick intro. I don't know if we have any questions or anything yet.
Any questions so far?
Anybody have any questions to what we've seen? We've got the Libs over here, and we've got XRF. And while you're all thinking of your interesting questions to ask, I'll continue talking about things I think are interesting, like our academic loaner program. So we're doing we have a standard academic loaner program where we reach out to people in academic space, students and researchers, professors, and we loan them an instrument for, typically it's only a couple of weeks to a month, maybe. And they use our instruments to do some cool new project. Maybe they didn't have the resources to do before, or maybe they've been using some complicated lab technique to get the data for that project, and they want to try something a little simpler that provides instant results, something like a Libs or an XRF. So we've had this program going for a while now, and we have a special AGU promotion going on where if you want to submit your ideas for an academic loaner, we're going to pick one or two lucky applicants to participate in a semester-long loaner. So it's kind of 3 or 4 times longer than a typical loaner, so you could really do a pretty in-depth project with that amount of time. Not only could you use it for your research project, but you could also use it in a teaching environment. I know a lot of professors love to use these kind of things to kind of get data quickly, to do a quick lab demonstration, or teach their students about some scientific concept without spending days or weeks in a lab just to get the results. You can run a similar experiment here and get the same test results within a few seconds, as opposed to all the, some lab techniques that may take a lot longer than that. So you can kind of spend more time on on teaching the scientific practices and the ideas, rather than all the technique involved with whatever particular lab technique you're using.
Where do they go to find more about that?
Yeah, so what I'm talking about, this special academic loaner, is you can find that on our website. There's also links through our AGU booth, where we describe what the academic loaner program is, and also the academic@sciaps.com email address. That's where you would submit your project proposals. And sometime after AGU is all done, we'll be picking lucky winners to have their semester-long time with one of our instruments here. So that's just an exciting promotion. I think am I missing any details there? Or
Nope, I think you hit the nail on the head. We'll choose 2 to 3 lucky winners, and they'll get a semester-long use out of one of our analyzers.
Yeah, so that's a pretty cool thing we've never done before.
We got a shout out from Quantum RX, French distributor of our products. Hello.
All right. Hey guys.
Thanks for joining us. Okay, and a question from Marco. Can you explain in a few words why should I use Libs instead of XRF for geo application and vice versa?
Yeah, great question. Thanks, Marco. So the main reasons you would want to use a Libs for geochemistry applications as opposed to an XRF, the primary one is if you're concerned with elements that you can't measure with XRF. So, for example, if you need to measure lithium or carbon or hydrogen or lithium, beryllium, those are all reasons to choose a Libs, because there's no way you could do that with an XRF. Secondly, the next up would be maybe you live in an area or you're traveling to an area where X-ray regulations are a little tough to get around. You don't have any of those X-ray regulations with this because it's a laser device. So if you're kind of plagued by X-ray regulators, then the Libs is also a good alternative. Alternatively, you may want to use an XRF if you don't care about those elements. And the other strength of XRF is that you're more likely to get good answers right out of the box, because it's less matrix dependent than Libs is. I mentioned before, to get good quantitative results with Libs, you really have to do a matrix match calibration. So usually we'll ship it with a factory calibration, but we generally encourage our customers to spend the time collecting their samples, their standards, known samples to calibrate with, so that they come up with a calibration that matches the types of materials they really care about. That's how you're going to get the best results with the Libs. With XRF, although we allow you to do that with our software, generally you get really good results right out of the box, and you don't have to tweak things at all. So those are that's another big difference. It's kind of like ease of use and kind of out of boxness, if that's a term.
It is today.
So thanks for the question.
Do we have any other questions? I am excited to see your mailers routinely. Would like to represent your organization in India. We will reach out to you. Definitely. Thank you so much.
Thank you.
mailers being the email?
Yes. Especially the low-cost PMI and Z series for carbon. Yes, definitely. Okay.
How are we doing on time? We got maybe
We have about 10
7, 8 minutes,
left.
yeah?
Maybe we could go over our customer
So-
service program.
Yeah. Yeah, so another thing that kind of sets us apart as a supplier and manufacturer and designer of these instrumentation here is our customer support and service costs. So we like to look at our service costs, our service program as more of a customer loyalty program as opposed to a profit center. So please check out our website. We list some of our costs there. But for example, typical repairs on the Libs are on the order of a few $100s. So that's really quite cheap when you consider the overall price of the instrument. And we try to keep those costs as low as possible because we want our customers not getting gouged every time they maybe have a mishap or something goes wrong. So that's something we really pride ourselves with, is offering great customer support and service costs. Another testament to, on the flip side of service costs is ruggedness. And we had a recent story with our X550. Someone was actually using it for testing some metal parts up high in a tower about 35, 40 feet. And while they were doing their job, something happened, and the analyzer actually fell off the tower 35 feet to the ground. He picked it up. It had a pretty bad gouge on the side, but it still worked. So he could have finished off the job if he had to. He sent it back here. We did a complete check of it. Everything was in working order. It just had a little damage to the housing. So I think all in all, it was returned to that customer with only about a $500 repair bill. So not only are repair costs cheap, but the analyzers are very rugged, which is important for portable instrumentation where you're bringing them out to the field, and it could be a desert, could be a mountainside, could be the top of a tower. So we like to design our instruments for where they're going to be used, and we know people want to bring them to pretty rugged areas. I think Bianca's going to drop in a couple of email addresses into the chat just so you know how to reach out to us if you have any other questions, or if you're interested in the academic loaner program, or if you have technical support questions. We'll have some links in the chat there to reach out. Let's see. So if there are any other questions,
5
we
more
could
minutes.
talk about that.
Yeah.
Anything we want to do a sample testing?
Yeah. I guess we could just shoot a few more things with the Libs, get a feel for how this works. Actually, Rick, if you don't mind holding it above, maybe I can run samples. People can see it actually run.
Yeah, go right ahead.
So,
I don't mind doing it this time. I'm kind of ready to go.
all right. So I'm gonna just hold a sample, another mineral sample up in front of the analyzer here, and hit start. This is a nice view. You get to see the plasma forming on the sample surface, and this is another interesting sample that would be tough to do with XRF, and that's because of this first element here. So that's beryllium. You can see we're seeing a ton of beryllium here, and that's because this mineral is beryl. So another example of, maybe you're looking for a quick way to identify minerals in the field, and I'm not a geologist, but I know there are plenty of geologists who pride themselves in their ability to identify minerals, but even the best have a hard time with certain minerals. There are several that are just white white in color and could be easily confused with different minerals of the same kind of look and feel. So, but what's nice is with a quick zap with the libs, you get a full breakdown of the major elements and even the trace elements too. And in this case, you see beryllium up at the top of the list, and that gives you a really good idea that it's a high beryllium mineral, and that's beryl. So, yeah, just a real simple demonstration of how the libs could be used for helping with mineral ID and things like that. So then, if you wanted to actually quantify some of the elements in minerals like beryl, that's when you'd go and maybe find a bunch of standards. Maybe you have mineral samples that have already been analyzed by a lab. Then you can grab those samples. You can program them into the PC software, connect the libs, shoot the samples. You can build your own calibrations from scratch that way. And then once you have that calibration, you're ready to go shoot unknown samples and get quantitative numbers. So you could know exactly how much beryllium or lithium or whatever is in those samples.
And the software is called?
And that software is Profile Builder. That's our PC software that's used for calibration building, spectrum analysis. You can do some really cool things with it. And check our YouTube. I think there's a few examples of how that works.
Mm-hmm. Do we have any other questions before we wrap up today?
One minute.
So I guess maybe I'll just recap while we're wrapping it up here. We've got, my name's Morgan.
I'm Bianca.
And we were here today talking about the SciAps, the two main SciAps product lines. We've got Libs and we've got XRF over here. Both are handheld instrumentation you can bring out to the field or use in the lab. They give you elemental analysis quickly within a few seconds. And they're great tools for your field work or research or even as a teaching tool. So thanks for your time today, and hope everybody's having a good virtual AGU. And we'll talk to you again tomorrow.
Bye, guys.
Okay.